The stage is yours.
Yes, it's quite long. Hey everyone. Wow, I need to tell you that I'm quite surprised about the size of this place. I didn't expect first such big hall and so many people at the audience. Let me maybe start with some introduction. My name is Wojciech Nowak and I act as Gen AI Tech Lead at Raiffeisen Tech. I have two specializations. The first is modern data architectures, the solutions like data mesh and data fabric, and the second is the making AI use cases production grade. Today, exactly as Jakub said, I will be talking about the one of our use case. This is the project we started in June, maybe July. And we got quite promising results, and we hope actually continue this progress, at least at the stage we hope that we keep getting promising results. But maybe let me ask you a few questions, because I like to know to who I talk. So anyone who is complete beginner to AI? Okay, no. Anyone who has a problem personally or within the organization, or problem or the challenge, and wants to know how to deal with tabular data? Okay. Anyone that uses the AI agents? Okay, that's nice. Okay, so I need to speed up the pace a bit. So let me start with the question: why you should listen the presentation. So first of all, as I mentioned, if you had this problem, how to deal with tabular data, you are in a good place, because we beat an MVP with some, I would say, promising results. And also what we did in the team, we made kind of a research that has shown us some promising directions. And I'm going to present it to you. First of all, okay, not the first of all, but another argument is that you see the big changes happening actually right now, and the size of this change will be, I would say, enormous, because the impact would be exponentially greater than the change that happened more than 100 years ago, which is, as you can see at this slide, the change which was presented is the rise of automobility, right? On the first photography, you can see only the hackneys pulled by the horses, while the 13 years later, there is barely one horse, and to find it, you need to look very carefully. So, you know, the change that is happening right now will have exponentially greater effect. You see, in 10 years, since now, probably each of us would have some personal agent. And for example, to book a table in the restaurant or book a visit in the hairdresser, in a hair salon, you would ask your virtual assistant to contact another virtual assistant to actually book the slot for you. And so I believe that, you know, like being at such places and sharing some thoughts is actually very important for us, because what we can achieve by that is some synergies, and, you know, in the few weeks later, at very random place, some ideas, some quite a good ideas after listening different speeches came to our minds. And you see, the company I work for, the Raiffeisen Tech, is also understanding the matter of this change. So the Raiffeisen Tech is the technology center that supports Raiffeisen Bank International in its AI transformation. And AI transformation in the RBI Group has two pillars. The first pillar is AI Pioneer Program, and the goal here is to educate employees of actually the company to adopt AI. That means to provide training, that means to provide tool, and finally the space to actually grow and somehow adapt the AI. Because you see, the AI will not be the technological change. It will be, first of all, like cultural, organizational change, which is possible by the advancement of the technology. such as AI. And the second pillar is the AI Center of Excellence program, which is actually built. And the goal here is to build a set of use cases. The use cases that would actually that are aimed to increase the efficiency of some processes that are happened within our bank. And one of the use cases is AI sales assistant, and actually it's, I would say, one of the core or leading use case. Or we can also ask your data chatbot. So the goal here is to build Copilot or the chat, which will help the users of our group CRM platform to increase the efficiency. We aim that the chatbot would take the tedious and repetitive tasks of relationships manager and free the resources to do some creative work, at least more creative work. So we aim to provide 360-degree view of the sales-related data, and we also hope that we aim to combine those data with reasoning capabilities of LLM. And you see, by accident, okay, this is not accident. This is rather the way that the advancement in the technology and the data went through. But the data that holds value within the companies with I would say the big past or with some history, such data are structural. So we want to take the data from the three areas: the data about sales activity, the data about some offering performance, and the customer assessment data. And our business colleagues expect us that we, at the first stage, will be able to analyze the data with different dimensions as a product, as a customer, and those analyses would be multi-level at the many levels at the same time. What's more, actually, what's the second stage is, or second step, is to increase the cross-selling and then upselling opportunities by some recommendations, which would be made on this data. And the third, I would say, third thing we would like to achieve is to build reports and dashboards while which are being declared or defined in natural language. So you see, the expectations that are ahead of us are bold, but with the bold expectations, actually the great products often starts with the bold and ambitious expectations. And to be honest, in order to build such products, we need to have some pragmatic approach and go step by step, like that. So let me very briefly start with the architecture of our MVP, which is what we built. So here is a very simple agent. It consists of some communication with LLM model, obviously some query tool, which, for those who don't know what it is, it's like similar mechanism to the function calling. I will explain it in a moment. And then this tool to connect to the storage system, and this whole process happens, I would say, in the loop. And finally, after a few possible iterations, the happy user gets his message back. I will go to the details for example, of this architecture. Why it's first of all, it's very simple, but with the simplicity comes power with some aspects, but I will kind of mention it in a moment. So let me explain some Gen AI concepts, because I'm not that sure if I want to be sure that we are on the same page. So you see, we've got the following problem with the Gen AI. The models has been trained some time ago. So if we would like to ask the model for the current data, for example, the stock price of the RBI company or the IBM, the model who has been trained, I don't know, like a year ago, does not have this data. So what can help us to solve this problem is function calling mechanism. We ask the very same question, but at the same time we actually provide a tip to the model that, hey, here is the function that you can use, and and that function will get you the data you want, right? So here is how the communication goes through. You ask the You ask the question, LLM model asks you to do the call, you or some application provides the response with this additional context, and then the stock price is returned in the answer. The second thing is AI agents, and AI agents are entities who can solve relatively complex tasks depending on the setup of those agents. So what they can do, they can break down a complex task into smaller questions. Then those questions can be executed accordingly depending on the plan. The next step is actually to execute some steps. Our agents might use some tools that we will provide to them. And finally, to be able to kind of orchestrate it and lead the whole process, they are able to memorize the steps or the tasks already completed. Here is how the flow of such agent looks like. It's really simple, similar to the function calling. The only difference is the loop. At the somehow abstraction, some let's say high level abstraction, because down there in details there are some subtle differences. So there is some call or some message to the LLM model, right? It can decide whether it should use the tool to answer the question or not, and it also needs to decide whether it needs to use the tool one more time and one more time up until it decides that no, I've got everything I need, so I can answer the question. And yet another thing that is important to understand the further parts of this presentation is the textual SQL mechanism. That's relatively simple and is based on what I said. So it is composed of 3 steps: query synthesis, execution, and answer generation. So the user provides some query in natural language. Then, thanks to the function calling mechanism or tool abstractions, what we do, we execute the query. We get some table, and we just actually output table, which is the result for us, and then the answer is generated based on this user query, and the table as some additional context or some augmentation. Now I'd like to be back to the MVP details, because as I mentioned, some aspects of this MVP now, especially the open architecture, can be presented, because you see, with the MVP, if it's properly designed, we can easily switch different domains, different data sets. What's more, we can easily switch the instances or the types of large language models. We can switch let's say the augmentation context. We can switch the query tools and the storage systems. So it allows us to test different tools in quite, I would say, quite quickly, and without writing complete new solution. So how effectively does our MVP perform? And the actually results surprised even me, because we achieved the 95% of accuracy for aggregation queries that require multi-dimensional analysis. Obviously, to achieve this, we need to train. We need to know how to write the query. So that's one, let's say, condition. So we need the relationships managers who would be talking with the chat to know some prompting techniques, or what about they should ask. There are a few other conditions, or for a few other. For example, we need to provide some additional context, right? Because the model needs to have the knowledge how to interpret the data and so on. But you see, once the task complexity of the task grows, the single agent pattern does not perform sufficiently well. It's because the too many tools that we have provided to the agent, or context is too wide. So, like for example, if you want to solve 3 different problems in one agent, providing him like 10 of tools, he might get lost. But that's exactly what we would do if we would, without having specialization. If we would, I don't know, for example, if someone asked me to do some radiology description, right, I would know how to do it without specialization. So you see, the single agent, I would say, pattern is not able to provide good results because of the way it's designed, right? Because of this context of some capabilities of understanding stuff and lack of specialization. And luckily, we got the plan to increase the performance of the chatbots in complex tasks. For example, especially in reasoning tasks, in providing the detail, in providing the answer why something has changed. And by this I mean, for example, if we're analyzing the trend of the chatbot, we want to ask the chatbot why it happened, because for now that's the complex enough task and it is not able to answer that kind of tasks. So the answer how to tackle such problem is the multi-agent system, and here you can see a few topologies of the multi-agent system. The most popular is probably the supervisor, then there is the hierarchical, which is kind of an extension, and then is you can also define some custom architectures. The funny thing is that you see, if you analyze the hierarchical system and supervisor system, these are designed how we design the teams in the companies. So this is actually the analogy, and maybe we should have this in mind. Then in similar way we should build an agents. And multi-agent systems have few benefits because they allow us for some modularity, not only at the architecture level, but those single agents are easier to test, to maintain, to develop. The other thing that single agents miss is the specialization and the control, which is that we need to control some edges or some boundaries of single or of the group of agents behavior. And here, small announcement on the DevAI. In 2 weeks, I will have a more technical presentation when I will introduce the how does the GenAI agents work. With Llama Index, we will start with some simple function calling mechanism or React mechanism, and I will try to explain how to build a multi-agent system, and I will try to do it in half an hour. We will see if it's possible, but I will do my best. So you see, here is the architecture that we are planning to build. It follows this supervisor paradigm. So we've got some supervisor agents, right? Then there are, let's say, 3 worker agents. The first to the query synthesis, which is actually generates 1 or 2 queries or a few queries, SQL queries that helps the chatbot to answer the question they are asked. Then there is a query task execution agent, which what it does is execute the task, and finally, after having those steps executed, the generator agent is able to provide the answer, which is further passed by the orchestrator to the user, and hopefully the user is happy. And you see, if I was doing this presentation a couple months ago, it would be end. I would say thank you very much. Maybe we would have no, that's not the end. Let me finish.
That's fine.
I would do some Q&A session. Maybe I would even add some slide about evolution of GenAI. I will also increase to actually take some place in the slide and make the presentation longer. But I've got a surprise, because recently I came across something interesting, and I did a research especially for you. It will take about 5-10 minutes.
Okay.
So I came across something interesting, and we need to go back for this text to SQL approach, right? Do you remember 3 steps, right? Query synthesis, execution, and answer generation. And what I came across is the table augmented generation. This is based on this paper. You can use the QR code to check it out. But what it does, it combines the actually capabilities of the databases, which we use as in classical text to SQL approach, but also what it does is somehow leverages some word knowledge and reasoning capabilities of large language models. And when you deep dive, actually when you open the paper, you would see something which is quite similar to the text to SQL, which is the very same steps. You would see this, let's say, execution pattern, right? But if you zoom in to actually this SQL-like query that is generated, you would see something interesting. We've got the LLM code here. And if you read carefully enough into the paper, you would notice that a part of having the call to database, a part of analyzing the results, what it does, it also operates over some. It also does some operations with usage of LLM calls. So the tag query, the one which I show you, right, which looks SQL-like, has two components. The first is obviously SQL, and the other is this call to LLM. But what about this? What about this LLM call? So here another paper call comes in. Actually, the paper was developed by the very same group. It's called Lotus Enabling Semantic Queries and so on. And what it does, it provides some queries that allows us to actually employ those semantic queries, which could be filtering, which are aggregations, which are some joins, or their limits and stuff like that, and do the analysis over the data set that we are interested in. You see, but there is a problem, and it's not like the world would be too beautiful if it would be ready and we could use it seamlessly, because you see, it is not production ready. What they propose some model that they did some benchmarking testing in this tag paper, the very first one I presented to you. And the results are promising, but the framework is not production ready. However, they strongly recommend us to play further with this tag approach. So we accepted the challenge. And I believe that in the bank, at least that's the plan, that we would be able to make it happen. But now the question is how? And you see, I've been thinking, and this modular architecture allows us to do it. Because you see, we can, a part of having the model that is generating the text to SQL queries, we can prepare the model that is doing text to semantic queries, right? Also, the very important thing here is that having those subtasks needs to be optimized, because the production data, the size of production data in modern companies are really big. So, and even though this Lotus framework has some optimizations, it needs to make certain amount of calls to actually being able to analyze those data. What are the further modifications? We have the query semantic tool, right? That makes the call to LLM, and the answer generation model is working accordingly. Yet another QR code. Here is the repository. You can use to play with it a bit. Because frankly speaking, it might be quite hard to build it. But I believe that at least playing with the notebooks or with the sources that the community somehow built, if not, would help us to make some improvements that at least we would learn something that maybe someday we will use. So you see, we started like a few days ago building this post MVP. So we are at the very initial stages, but at the very initial stage of it, and there is very interesting journey ahead of us. In a few months, I hope I will be able to share some thoughts about how it went, if we build the chatbot, if it's kind of agree with what I presented, because Obviously, you know, the architecture might change. Maybe we would fail with those tag approach. But if you are interested, in following the progress, you could either contact me, you can follow me, you can add me to your network, because I'm only on LinkedIn. You can also catch me somewhere on the hall or here. We can talk. I will share I will share the. Okay, I will not share the QR code. So yeah, okay. But very briefly about the bibliography. Thank you. Oops. Hello. Okay, so if anyone needs QR code, and that's it from me. Again, thank you guys. It was it was a big pleasure. Thank you.
You sure you don't have any slides? Because I did the false start before. So no, we have 8 minutes. So yeah.
First of all, great presentation. I have a question about LLM models. You are a bank after all, so I would suppose that you wouldn't be able to use open big models hosted like Azure, like Sonnet or something like this. You had it on your presentation. Yes. So a few words about it and a few thoughts about fine-tuning models before doing the all display. Okay.
So regarding models, what I wanted to present in this slide where I talked about open architecture, I didn't kind of referring to the bank itself, because you are right. We cannot use like custom models, and each model that we are using needs to go through some regulatory and security processes. So that's true. But the goal there was to kind of show many aspects of this open architecture. And the second question was, okay, fine tuning. So to be honest, that's still ahead of us. Hopefully because I've got some roadmap in my mind, and hopefully in February we will start doing some fine tuning, because the challenge with fine tuning is we need to have the data. And what we started doing with the MVP, we gather the data, we gather all interactions with our business stakeholders who are actually checking how the model performs, how the model acts. So as everything takes time, right? So we need to be patient, we need to prepare for it, but definitely that's one of the steps you want to make and explore.
Thanks for the presentation. I have a couple of questions. First of them, actually, what kind of programming languages and special libraries are you using for orchestrating that multi-agent system?
Okay, so we are writing code in Python. Everything is run by the Databricks. Okay, the application itself is running temporarily on the Beanstalk because it's like a demo, and we are using Llama Index, as I mentioned in one of the slides. That was company choice. I didn't kind of argue with it. I decided to go with it, explore it, and it also offers some multi-agent building capabilities similar to the other frameworks, like I don't know, LangChain or probably there are at least few others, right?
And the other one, actually, have you tried using that multi-agent system for managing the data privacy breach cases?
Oh yes, no, we didn't yet, but that was because authentication and ensuring the proper granting access is a huge challenge. I'm aware, or we are aware, that it will come, and we believe, at least we will try to build either some security guard that will manage to the permissions to the data, because we cannot access the master data to all the users. So that's a very good question. That's a huge problem. We know it exists, but again, we started in June or July. So we had to build a team from scratch. Even though we had some help from the colleagues from Vienna, we had two more use cases. So I just wanted to share some nice things that we are doing, and maybe I will be able to tell something more about in a half year, right? Once we progress with the chatbot.
Yeah, thanks for your presentation. Regarding, I have two questions. The first one is, you mentioned that the system needs to consume meta information to generate SQL. So if you can elaborate on what kind of meta information you provide to your agent. And the second question is about the benchmark. You mentioned 95% of correct answers. Can you again elaborate on how did you construct your benchmark?
Okay, so benchmark is very simple. We have built a set of, I would say, 25, 30 questions, multi-dimensional. The questions that requires multi-dimensional analysis, and we check it against the database. So that's what we did. Yes, and the and the first question was about, forgot. Meta information. Okay. So, the obvious things for us is that in order to do some work, we need some context. The similar mechanism is with the agent, right? So naturally, we provide the description of the table, what it can do with the table. We provide the description of as concise and as exact as it's possible, obviously, because of the way how does the large language model works, and so we provide this description of each attributes or some keys and so on. And what also improved, and because obviously the quality of the data, that's for me as a data person who have passed in the data engineering. I spent like 5-6 years in data engineering, so the quality of the data matters, and that's second thing. So a part of the description of the data, you need to have proper quality data, and if there is some ambiguity in the data, or if the model is not performing with some type of question well enough, what you can do is you can provide some guidelines, exactly like you would tell it to your colleague. That worked also quite good.
All right, thanks. We have time for one more, maybe.
Thank you for the presentation. One question regarding this 95%, because it's like I still didn't hear the answer. What exactly do you divide by what to get that number?
Okay, so the number of samples through the corrected answers, because what mattered for us was the exact number provided at the end.
And that would to ask the question about the type of model that you use to generate the SQL queries.
I guess it's GPT-4, but it's somehow GPT-4, GPT-4o. But I'm not sure if it's if it isn't. Either it went through the security process of evaluation that we can use it, or it's somehow hosted. I know that's for all. We have our custom instance hosted on our own servers. Yeah, that's it I can talk about at the moment.
Okay, thank you. I think we're kind of on time, so thanks the speaker again. Thank you.
If I may, once again, thank you guys very much. Yeah, I didn't expect such audience. You were wonderful. Thank you.
Thanks.